Hello everyone. In our previous video, we have learned about performing calculations on logarithm. So let us move ahead and apply those learnings in solving some of the numerical examples on pH. Let us take a solution of 0.01 molar HCl, that is an acid, and try to calculate the pH of this solution. We know from our previous discussion that for calculating the pH of a solution, we need the H plus concentration in that particular solution. By taking the logarithm of H plus concentration to the base 10 and then taking its negative value will give us the pH. Now we will apply this formula in calculation of pH of the mentioned solution, that is 0.01 molar HCl. The HCl solution furnishes H plus and Cl minus. Alright. Now since HCl, hydrochloric acid, is a strong acid, whichever amount of HCl we have taken in the solution, it will dissociate into H plus and Cl minus. So here we have taken 0.01 molar of HCl. So entire amount, that is 0.01 molar HCl, will break into 0.01 molar H plus and 0.01 molar Cl minus. Now for calculation of pH, we are concerned about the concentration of H plus. So here is our H plus concentration in this particular solution. After knowing the H plus concentration, we will simply put the value of H plus in the mathematical formula of pH. So we will put the value 0.01 in place of H plus concentration, and now we will move ahead performing various mathematical operations in order to get its value. We can write 0.01 as 10 raised to the power minus 2, and we also know from our previous discussion that such expressions in which we have an expression in the form of a given number to the power some number can be expressed or can be simplified by simply multiplying the entire expression within logarithm by that particular exponent. So this entire expression can be simplified further in this manner. And also we have noted that logarithm of any number to the base itself will always be equal to 1. So here logarithm of 10 to the base 10 will be equal to 1. So we will put its value in next step, and after solving we will get the pH of this particular solution as 2. We just saw the calculation of pH for 0.01 molar HCl solution. Now let us see an example in which we have to calculate the pH for 0.01 molar H2SO4 solution. We have kept the concentration of the acid same, and we would like to learn what difference it is going to make if we change the acid itself. Alright. So in case of HCl, we saw that the concentration of H plus produced was same as that of the concentration of acid, that is 0.01 molar. This is because HCl is a monobasic acid. Monobasic acid means its 1 mole will produce 1 mole of H plus ion. However, H2SO4 is a dibasic acid. Alright, so the dissociation of H2SO4 will take place like this. That is, 1 mole of H2SO4 will produce 2 moles of H plus ions, and this type of acids are termed as dibasic acids. And due to this fact, we are taking the concentration here as 0.01 molar. At the concentration of H plus will be 2 times of the concentration of acid, that is 0.01 times 2, and it will be 0.02 molar. And we will take this concentration of H plus to perform further calculations. Now let us see another variation, another possibility of pH calculation. Again, we have kept the concentration here as 0.01 molar, but this time we are taking a weak acid. We have ensured that both HCl and this particular acetic acid is monobasic in order to keep our comparison ideal. However, in this example, we will notice that the concentration, whichever concentration of acetic acid is present in the solution, that is 0.01 molar, it will not dissociate completely. Okay, so 0.01 molar tells us that there are 0.01 moles of acetic acid are present in 1 liter of the solution. So this entire molecules 0.01 moles are not going to dissociate because this is a weak acid. Only a fraction of this many molecules will get dissociated into H plus and acetate ion, and hence we can expect the concentration of H plus right here to be less than 0.01 mole. And for further calculation we would require more information in terms of its dissociation constant, that is often designated by the letter alpha. This alpha tells us the fraction of the initial molecules that actually dissociated into its constituent ion. Okay, so from this 3 set of examples we can conclude that for calculation of pH of an acid, first of all we would be requiring its concentration, then we would also require its basicity, and finally we would require whether it is strong or a weak acid. By having this 3 informations in our hand, we can follow similar approach by calculating the H plus ion concentration that will be produced from that particular acid, and we can use logarithmic tool to calculate pH. Thank you so much for watching. I hope now that you can perform basic calculations required for calculation of pH of different types of solutions. However, we will be discussing more examples, more variations of calculation on pH in our upcoming videos. We will be taking examples such as mixing of acids or mixing of an acid and a base. All we need to take care is to track the concentration of H plus. That will be very fundamental for the calculation of pH. You can also refer the previous video in this series in which we have defined pH. After all, why we are learning this and how does it helps in our study. Okay, so thank you so much for watching once again, and See you on the next video.